Hello, thank you for joining us tonight for our January 2021 Fundamentals program of the Naperville Astronomical Association. Just a quick reminder, you can maximize your view by clicking the little maximize button in the corner. Make sure the audio is how you want it. To ask questions, you can ask your questions on Facebook, or you can email us at feedback@naperastro.org, and we will see those questions and we'll try to answer those live. So tonight's program is about using your new telescope. You know, it's shortly after Christmas time, so we're assuming that some people maybe got either a family present or somebody got a new telescope for Christmas, and you might not know how to use that very well. So hopefully we can demonstrate tonight a few techniques on how to use your new telescope. So some telescope basics. Try to read the instructions if you can. I'm not necessarily an instructions guide, but it really will help if you can sit back and take an hour and try to read those instructions. You should set up your telescope inside at least one time before you set it up outside. It's cold outside right now anyway, so you know, it's a good thing to set it up indoors, because when you do it outside, you might drop a little screw or drop something that you know, you're gonna regret it falling into the grass and you not being able to find it. Another really important thing is, do not invite the whole neighborhood over the first time you take your telescope outside. Nothing ensures that you're going to have more problems than a crowd standing there watching you. So use it yourself at least once, maybe twice, maybe 5 times until you get the hang of it. And then once you get the hang of it, then you can start inviting people to look, because you'd be surprised how many people set it up in the backyard for the first time, or take it on vacation up, you know, where it's really dark and don't know how to use it. Another thing, you need to set proper expectations. So today, you know, you can Google anything on the internet, and you know, you can find the Hubble views of galaxies and nebula and star clusters, and they all look beautiful, and that's not what you're going to see through your telescope in your backyard. So you need to kind of understand the views you're going to get. So these are a couple telescope boxes, and the one on the upper right is an ad for Walmart for a telescope. They show right on the box, look at these beautiful things you're going to see. And the prettier the picture, the faker the telescope is, I guess. Because you know, to see, this is the Andromeda galaxy up here in the corner. That's, even in the darkest skies with the biggest telescope, it's not going to look that pretty. So again, this is a Hubble image of what's called the Pillars of Creation. This is located inside the Eagle Nebula. So this is the Hubble image, and this is probably more along the lines of what you would see through your telescope. This is a M13, the star cluster in the constellation Hercules, just a beautiful star cluster. It's probably going to look a little more like that in your telescope. So where to set up your telescope? The first thing, you want to be outdoors. I know it's cold out right now, but you don't want to try to use your telescope through the window. You're going to get glare. It's just not going to work very well. Whenever you're adding extra glass, it's not going to do well. So you really do need to take it outside. If you can set it up in your backyard, like in the darkest part of your backyard, where you can see the most sky. So if the only area of your backyard that's dark is right under a tree, that's not gonna do you any good. So you know, you need sky to look at. So, you know, pick the place as best you can, but if you can avoid any kind of outdoor lights, do that. Avoid surfaces that vibrate. Decks are notorious. They're just going to shake every time you take a step or move the telescope. It's going to vibrate. So try not to set up on a wood deck. If you can, avoid looking over the top of buildings or parking lots. These things, the heat during the day from the sun will kind of soak into these things, and at night the heat waves will still come off of these things. So you'll get kind of a wavy view. Whatever you're looking at is going to bounce around a little bit because of these heat waves. Try to shut off all the outdoor lights that you can. Don't look at your cell phone. Use red lights. You want your eyes, your pupils, to get dark adapted. So the best thing I can kind of say about this is that if you wake up in the middle of the night and you go to the bathroom, you can walk to the bathroom just fine with no lights on. But you turn on that bathroom light after you use the bathroom, you shut it off, you're bumping into everything on the way back to your bedroom. So when your eyes are dark adapted, you really can see very well in the dark. But as soon as you get any kind of white light, your pupils are going to shrink and you're not going to be able to see as much. And one other thing, place you can set up your telescope, if you're a member of the Naperville Astronomical Association, you get access to our dark sites that have less light pollution than downtown Naperville does. So to talk about light pollution, it's about an hour southwest of Naperville. So this is a map of the light pollution in the U.S. You know, here's about where Chicago is. You can see that it's pretty bad. Zooming in a little bit more, this is kind of the area we're in. So the closer you get to black or blue or green, the more things you can see. The closer you are to white, the less of the sky you're going to be able to see because of light pollution. So it's difficult to see a lot of things from this area just because there's so much light pollution coming from Chicago and coming from the cities around this area. And having said all that, the Naperville Astronomical Association sets up on the downtown Naperville Riverwalk with lights everywhere. Buildings are lit up, so you can view it during the, you know, with a lot of light pollution, but if you can avoid it, it's better. Typically, what we look at is more of solar system objects or some of the brighter objects. So some of the things you can still see with the lights being as bright as they are, but if you want to see dimmer objects, you need to get under darker skies. Okay, so you got your new telescope. It probably came with an eyepiece, and maybe you've decided to buy your own eyepieces. There's really 3 different kinds of eyepieces out there. There's 2-inch eyepieces. Now for this, you would need a 2-inch diagonal, or it'd need to go into a 2-inch focuser to use. Probably most of the telescopes that beginners have don't have a 2-inch diagonal or focuser. 1.25 inch. This is the kind of the standard. 1.25 inch will work in a 2-inch diagonal or focuser, but you need an adapter, and that usually comes with it. And then there's these older 0.965 eyepieces. You really don't see these anymore. You might see it if you're looking for stuff on eBay. I would say just avoid that if you can, because there are adapters for those, but you want to go with 1.25 inch or 2-inch eyepieces. Okay, so this is the most important thing to remember about eyepieces if you're a beginner, is the higher the millimeter number, the lower the magnification is. And the lower the millimeter number, the higher the magnification. So if you have a 25 millimeter eyepiece, it's lower magnification than your 6 millimeter eyepiece. Now this is important because I'm going to show you a little bit of what that magnification is in a later slide. But just remember this: the higher the millimeter number, the lower the magnification. The lower the millimeter number, the higher the magnification. So these are two common eyepiece kits that a lot of people get if they get a new telescope. They go out and buy these kits. They come, Celestron is a 6 millimeter 8, 13, 17, 32, 2x Barlow, 6 color filters, and a moon filter. And the Meade's a very similar. It's got a 9 millimeter and a 18 millimeter instead of the 8 and the 17. Our website actually has this eyepiece calculator. So if you Google or search for the term Naperville eyepiece calculator or Naperville telescope calculator, you'll find this site, and you can put in the parameters of your telescope and put in the parameters of an eyepiece that you might be thinking of purchasing, and it'll kind of kick out some numbers that tell you whether or not that eyepiece would be a good investment. It'll tell you the power of the eyepiece. So if it's too powerful, if it's magnifying the object too much, it might not work very well for your telescope. So the Celestron 8SE is kind of a common telescope that some people buy. So I calculated the magnification for these eyepieces. Now the website for the Celestron 8SE says that 480 power is the highest useful magnification. That is in absolutely perfect conditions, the best night of the year. You might have, be able to get 480 magnification once the whole time you use this telescope. So in reality, most people try to keep it around 150 to 200 power. Once you start getting over that, the objects dim quite a bit, and this is more the sweet spot to not exceed this. So as you can see here, like a 6 millimeter eyepiece is going to be 339 power, and a 9 millimeter eyepiece is going to be 226 power. So both those eyepieces might be on an average night a little too much for this particular telescope. So that's why that eyepiece calculator can kind of help you. So if you bought that kit that has these eyepieces in it, there might be two eyepieces that you don't even use. So it might be more beneficial to buy eyepieces individually, to use that calculator to figure out what the best eyepiece to use is, instead of buying the kit. The kits are nice, but there's parts on the kit that'll probably go unused. A big misconception on eyepieces is, since you're looking at something that's really, really far away, you need to magnify that more. So you're looking at a galaxy that's 2 million light years away. You must have to magnify that, a lot just to see that. And the reality is that's not true at all. If you have like a 25 millimeter or 32 millimeter eyepiece, the 25 is what typically comes with your telescope. You'll probably use those two eyepieces more than you'll use your low power eyepieces. So if you're buying eyepieces separately, really focus on kind of a higher magnification, because you'll probably get more use out of that. Another misconception is that very expensive eyepieces are going to show you more. Often the more expensive eyepieces will give you a larger field of view, or might provide a little sharper image. It's deep down, it's better glass. It's not something that's mass produced in a way that's, in a cheap way. So these things will look a little bit better, but if you are looking through your telescope and you see something and you're just barely able to see it, and it's kind of a little fuzzy ball of stars, if you go out and buy a $500 eyepiece, it's not going to be 500 times better. It's gonna, you're probably not going to notice the difference that much deep down. So think of it as, some people drive a Ford Taurus and some people drive a Cadillac, and they both can get you where you're going, but one might have a little more leg room and be a little more comfortable to drive. So do not think that you need to buy expensive eyepieces to enjoy this hobby. the eyepiece, the 25 millimeter eyepiece that comes with your telescope will probably do the most of the heavy lifting that you need. Focusing your telescope, there are it's either going to be a knob or a wheel. So then the top right is a Smith-Cassegrain, and it's got a focusing knob, and that actually adjusts the internal mirror and moves that mirror around. The bottommost telescope is a refractor, and that's actually going to move the eyepiece in and out, and the same with the Dobsonian on the left. It's going to move the eyepiece in and out. And as you move that and get the object into focus, that's focusing right on your pupil to give you the most optimal view. So when your telescope's not in focus, it's going to look like one of these two things probably, if it's way out of focus. So the one on the left would be from a telescope that has a central obstruction, like a Dobsonian or Newtonian or Smith-Cassegrain. It's going to look like a donut. The one on the right is going to look like a plate. And when you're focusing, you turn that focusing knob. If this donut gets bigger, you're going in the wrong direction. So you want to keep focusing until this gets as small as possible. So again, you're going to take this larger disc, and you're going to turn that into a kind of more of a pinpoint star, and that's how you know you're really in focus. And everybody's eyes are different too, I should point out. So you might focus for you, and then you let somebody else look through it, and it might be a little bit blurry for them. So they might have to focus themselves. So like the planet Mars is really tough to see most of the time, tough to see detail. But if you have a big, a great big Mars, that's probably not Mars. Mars is going to be really tiny in most telescopes, but it's going to have kind of more defined edges. An unfocused image will be more like a kind of an amoeba that's jumbling around the telescope. Okay, so now I actually have a video, and this is me setting up a Celestron 8SC telescope. I'm going to set it all the way up to the point where I align it on the planet Jupiter, and hopefully this will help anybody that has this type of telescope align that for the first time. These videos will be available on our Facebook page and on our YouTube page later on. So if you do have an 8SC telescope, you can watch this a few times if you need some help getting these set up.
Hi, I'm Jim from the Naperville Astronomical Association, and I'm going to show you today how to set up your Celestron NexStar telescope. So here we have the mount. The first thing I would suggest is you want to get the telescope to a comfortable height. So I'm gonna take all the legs out, probably about halfway out. It's good for my height. You also have to think about who else is going to be looking at the telescope. If you're going to have kids, you might want it a little bit shorter, or want to have a step stool. But I'm just going to eyeball these about halfway out, and then I'm going to set it up here. When you set it up, you want to set it up on something that's very sturdy. Something like a deck would be too wobbly. The ground's good, or if there's a cement pad, that would be good. And then your telescope comes with this little bubble level, and I'm going to show you how we get this level. So the bubble level is a simple concept, but when you have three legs, it makes it a little bit difficult. So you have this little bubble in the center, and you want that to be as perfectly in the center as possible. So you set it down on your tripod. As you lift a leg, the bubble will go towards that leg. So the way I have it placed right now, it needs to go this way, which of course is in between two legs. So what I'm going to do is I'm going to lower this leg a little bit and see if I can get that bubble to go more to the center. So that's fairly good. I'm going to raise this side just a little bit. And I think that's a pretty good. I'm not going to pull the bubble level off yet because I need to put the the eyepiece tray on. Now this also acts to keep the legs out at the same distance. So as I do this, it might actually kick the telescope out a little bit, and which would force me to re-level it. Okay, so in my case, it didn't change the level at all, so that's pretty good. So I'm going to put this back in my pocket or in my eyepiece case, and we'll move on to the next step. Okay, now we're going to be placing this on. This is all the gears and motors that help track this. The easy way to figure out how this goes, it's got these little bumps that come out, and those bumps would be in line with little bumps on the mount. So as I put that on, you want to be careful not to drop this, but there's a little pin, and once it snaps in place, you'll feel it. And then you have 3 sets of screws. You want to screw those on completely. Okay, and then now I'm going to put the OTA on, the optical tube. So this, you need to be very careful. This is an 8SE, so this is an 8-inch. You want to get a good grip on it, get it about in the middle, and then tighten this knob on top. And really make sure that it's in all the way before you let go, because if you let go, this is going to bounce off the ground, and there's mirrors and glass and stuff in there that's not going to work right afterwards. So there's 4 different ways to power the Celestron Next Star telescope. There's batteries that you can put in here. You can use an actual power adapter, which would plug in down here. There are kind of these older style battery tanks. This uses a nickel cadmium battery. So the bad thing about these is if you run it below 50%, it kind of isn't good for the battery. And then the newer things that have come out are these power tanks that use lithium-ion batteries. You can run these completely dead. They can recharge like over 2,000 times, and they actually run pretty well. So lately I've been preferring this, but if I'm doing it in my backyard, I'll just use the power brick. The bad thing about the batteries is if you have batteries in it, it will default to the batteries first. So if you forget to take the batteries out and you try running it off of a different power, if these batteries go dead, your telescope goes dead, it's not going to automatically use a secondary power source. It's always going to try to use the batteries first. So most people that I know in the astronomy club don't really like the batteries. They're a little too finicky. So if you can help it, either plug it in with your power brick, or it doesn't have to be a Celestron power tank. There's other power tanks you can buy. Yeah, but typically people use some kind of power tank to power these. Okay, so I'm going to go ahead and use this power tank here. The nice thing about this is it's got a little wedge to wedge it onto your tripod leg, and it's got some Velcro to wrap around it to keep that on your leg. And then I'll kind of tuck it a little bit to the side. This will use, power will go here, and then the power will go up here. And then I try to tuck the cables away so nobody's gonna kind of get stuck on them or trip over them. Okay, so once this is ready, I do have to turn the power on this power tank. Now this one requires me to push the on button 2 times. I don't know why they designed it that way. But once that's on, we can power on the telescope. And the hand controller is now booting up. A really big, important step that you want to do before you start using this telescope at night is you want to align your finder. Now there's different kinds of finders. I'll go over that a little bit later, but the default finder that comes with this is called a red dot finder. And the concept here is we want this and the telescope to be looking at the same thing. By default, they're not going to look at the same thing, because if the screws are tightened slightly different, it gets off. So what we're going to want to do is point the telescope to something off in the distance, and then we'll try to get the telescope looking at that thing, and then we will try to get the finder looking at that same thing, and then we'll know that the telescope and the finder are aligned. This is a very, very, very important step. If you do not do this, you can point the finder at the moon, and if the moon's off to the side, you'll never find it in the telescope. So this is a very important step, and a lot of people don't do this step when they get these telescopes out of the box. So before we move the telescope to align the finder, we want to make sure we take the cap off. You'd be surprised how many people go out some night and have trouble and can't figure out what's wrong with their telescope, and they forget and leave this on. So a good place that we can go is to this electrical pole off in the distance. So what I'm going to do is, using the hand controller, I'm going to turn the telescope around and point at the very top of that pole. You probably want to do this during the daytime hours. It's a little trickier to align this at night. It can be done, but it's a little bit trickier. But what I'll do is I'll try to get it in the general area. I'll go down to the trees, kind of scan back and forth until I see the power line, or until I see the tower, and then I'll work my way up. So here I go. Oh, it's actually very close to begin with. But by changing these two things, oh my finder was a little loose. So by changing these two things, I'm going to get it to be the very, very top of the tower. If I look here, I'm still at the very top of the tower. So now this and this are pointed at the same thing. I cannot stress how important that is. Over some of the aspects of the NexStar telescope hand controller. I don't know why Celestron likes to change these up every once in a while, so depending on when you bought your telescope, some of the buttons might be a little bit different. They rename things, renumber things. So just because I'm showing you this way, read the button, don't pay attention to what numbers I'm telling you to do. As we turn it on, it starts up. The whole brain of the telescope is in this hand controller. So this is the NexStar SE, that stands for second edition. If you have a NexStar Evolution, these will be very similar, but maybe slightly different. So the first thing it tells you to do is press enter to begin your alignment. We're going to push enter. It's going to ask you what kind of alignment you like. So SkyAlign is supposed to let you pick any three bright objects, any three bright stars. They could be stars, they could be planets. It doesn't care, and the hand controller is going to try to figure out where you are based on those three objects. I haven't had much luck with this personally. It fails a lot on me, so I haven't really tried it that much anymore, but certainly you can try it. There's some methods that I like a little bit more. When it first gets dark, the only thing you can see in the night sky are the planets. So if you hit so these up and down arrows here is what's going to let you change. So auto 2-star, this is actually an alignment I like the most, but we can't do that until it gets a little bit darker. So we can go down 2-star line. Now this is different. So auto 2-star lets you pick the first star, and then you tell it the second star, and the telescope will get close to the second star. Close enough that you can probably figure out, if you're looking in the sky, you think, oh, okay, there's only one bright star that's close, so that has to be the second star. 2-star, you have to know the two stars that you're pointing at. So you tell it you want Vega, and you tell it you want Altair, and those are the two stars that you you do, but you have to drive the telescope to do that. 1 star line, typically the accuracy of this isn't that great because it's only putting 1 point in the sky, if your telescope's not perfectly level, if things aren't perfect, it'll get you something in a pinch, but I wouldn't recommend this one. Solar system align is one you can do when there's only, you can only see the moon, you can only see Jupiter, Saturn, or Venus, or Mars. This is actually a good one. This is the one we're going to do right now because I can see, it's just getting dark enough that I can see Jupiter. So I'm going to push enter to select solar system align. Now this is very important. So this is the time. Now some models have a built-in GPS, or you can buy an add-on GPS to these that will get the time and date for you. But if you don't have it, you need to look that up. So right now it is 4:45. We need to do it in military time. So that would be 16:45. The seconds really don't matter that much. I usually put it like at 30 seconds. And then I'm going to hit enter. Daylight savings, extremely important. Winter time, you are not in daylight savings anymore. You are in standard time. So that ends in 2020. That was like the first Sunday in November. So I'm going to change this to standard time. If you do this wrong, everything's going to be off by an hour. So if you think that if the telescope thinks that the moon should be in a certain position, when it crosses the meridian, the moon stops rising and starts setting. And if you're off by an hour, it's not going to track properly. So this is pretty important, or this is a very important thing that a lot of people get wrong. Central USA, that's where we're located, and the date. So typically it remembers the last date and time that you used. So today is 12, what's the date? 12/10 of 20. And then we're going to hit enter on that. So it says select the object. So we're going to select Jupiter. Again, these control the telescope. When you have to arrow up and down, you need to use these. So I'm going to arrow to Jupiter. And it says use the directional button, so that's these, to get Jupiter in our finder, which is this. So I saw Jupiter a second ago, and now I don't see it. Okay, so this is going to be almost impossible for me to show you, but here I have my red dot finder on, and if I get that right in the center, and you can't see it in the sky, but I promise you that there's a little glowing dot in the sky, which is Jupiter. So I have my red dot finder on Jupiter, and what the hand controller asked me is to center Jupiter in the finder, which I have done. So once I've done that, I'm going to hit enter. So Jupiter's in the finder. And then what it tells me to do, if I can get this to come in, is align Jupiter. So use my buttons to align Jupiter, to align object in the eyepiece. So what it's telling me to do is get the object in the very center of the eyepiece. This is kind of one of those do your best. They sell special eyepieces that have crosshair, that have reticles in it, so you can know that you're getting it in the exact center, but for the most part, this is just a solar system alignment, so it's not a big deal anyway. Once we do that, we're going to hit align. So earlier, when we got it in our finder, we hit enter. When we get it in our eyepiece, we hit align. Now it says star pointer off. So it's telling us to turn our finder off. So they actually know that you're going to forget and leave this on. So they tell you to turn it off. You're going to forget. Because I forget. Everybody forgets. But the hand controller actually tells you to turn that off. So, without further ado, let's see if there's any way we can get Jupiter to show up in the eyepiece. Where's my camera at? There it is. So, see a couple moons next to it. My camera's having trouble focusing, and it's a little too bright for my camera, but there we have Jupiter, dead center.
Just a couple things I'll point out is I wasn't really paying attention to my camera placement when I did the finder. So Drew's going to talk about finders in a little bit, and he'll show you how to adjust that finder. He'll show you that step. There's a couple little knobs on these finders that will move that little red dot left or right or up and down to get that aligned with your telescope. We do have a Facebook question. Joseph asks, when aligning your finder scope and are looking at a distant object, should you use a high or low power eyepiece in your main scope, or does it matter? Personally, I don't really think it matters that much. Probably if you were using a higher magnification, your finder would be a little more accurate, but I don't find that it matters. If you can get, because you're kind of eyeballing everything anyway, so if you can get the top of that cell tower in the eyepiece, and if you get your finder looking at it when you're trying to find something in the sky, you're going to be pretty close anyway. So personally, I don't think it matters. Probably some people would argue that it does, but I just kind of wing it on most stuff, and usually my alignments are fairly accurate. I don't see any other questions. If you do have more questions on the Celestron, we can answer those later. I think Drew is going to take over now. So I'm going to stop sharing, and Drew, you can...
You want to spotlight me? I'm not going to share. I'm just going to be on screen here. So, hi, everybody. I join Jim in welcoming you, and I'd like to add, gee, if you have your first telescope in hand now that you're just learning to use, congratulations, and welcome to the world of telescope users. Jim kind of started out with a little more complicated telescope. I'm going to kind of back up and talk about a little simpler stuff, and mainly going to use this fella sitting here as a demonstration piece. This is a fairly inexpensive telescope, like a lot of people might end up with as starting things. It's a reflecting telescope. It's on a very simple mount. It's what we call an alt-azimuth mount that just goes up and down and around in a circle. There's no motors on it. There's no computers on it or anything. So it's good for just demonstrating basic telescope things. I think I'd start out really enthusiastically repeating what Jim said at the beginning of his section was, don't try to learn your new telescope out in the dark, in the backyard, the first time. Set it up in the house at first. Set it up, follow the instructions, learn what the different parts are and what they do. Hopefully you got instructions with your telescope. If not, look them up here, look them up on YouTube or something or other, just to figure out what it is and how it goes together. Don't try to fumble assembling it and using it, pushing it around and stuff the first time in the dark. Second thing that's really important, well, I guess part B is Jim's note that, oops, there's a cover on the front of your telescope. I just dropped half of it. Important thing, save the cover. You need to keep your telescope clean, but when you go to observe, remember to take it off. It doesn't help things at all to have a cover on it. In inexpensive telescopes especially, but it can be true in any telescope, one of the big failures or semi-failures or problems that people have is with the sturdiness of the mountings. And if you set up your telescope and you find that it's really wobbly and shaky and clunky, that's not good. That's going to bother you every minute that you're trying to use it to actually stargaze with it. So there's a few things in setting up a telescope that you can do to address this. First off, all of the parts here, like the tripod assembly and even the mounting on something like this, there are various screws and nuts and bolts and knobs and things. Make sure things are tight. You need to be able to move stuff, but if it's rattly and loose, try to figure out why. If the tripod, which is oftentimes, again, sort of the weak point in inexpensive telescopes, if the tripod is wobbly, there's a couple of things you can do to improve it. First off, Jim showed you that most tripods are adjustable in height. Generally, the taller you've got the tripod set, the more wobbly it might be. So you might take some of the shakiness out of it by just lowering the legs some, even if it means you need to sit down or something to observe or sit on a stool or whatever, or crouch over. That might make it steadier. Another handy trick on lighter weight tripods especially is most of them have this spreader plate between the three legs. Jim's telescope had that as a loose plate that bolted up. A lot of, again, lighter weight tripods will have a panel in here that stays in place, or it's made so you can swing it down onto one leg so you can fold the tripod up. But tightening that up is good. Adding weight there can make a big difference too. If you have a somewhat shaky tripod, if you hang a weight from the middle of it, is a handy place to put things. They always put these holes in them for putting your eyepieces in. And I really have in my many years of observing, seen many experienced observers who end up actually lining their eyepieces up there, because what happens is they get dew on them or they get dirt on them, and it doesn't end up being sitting out there in space in the open air when you're outside observing is not generally a good place for your eyepieces. But you can use that panel to place weight on, or even I've seen people take like a gallon milk jug or water jug and put water or sand in it and hang that from here. Adding extra weight there can really stabilize your tripod quite a bit. So that's a trick too. So stability is really important. And again, that's something you need to play with. You might find when you're actually out using that, oh, I've noticed that there's something seems loose in here, and you need to look at that in the daytime. But working with that first before you, again, are out in the dark, doing your first nights of trying to observe things and point at things. Again, take care of that in the daytime beforehand. You need to learn the motions of your telescope and your mounting and how it turns. Jim's telescope, again, had motors on it that are steering it around the sky. This is a totally manual telescope. This is another one back here that's on a manual mount. Get used to the idea of that this goes up and down and around, and so you can point at any part of the sky, and what you need to do to make those motions go. Get used to the idea that on this telescope, once you put it at the right elevation, you really need to tighten down this knob on the side lightly to hold it in place. And then when you do that, this one has this feature on it where I can turn this little knob here on this shaft, and it makes a fine adjustment of the elevation. So say I've got Jupiter in there, and it's starting to move out of my field of view because of the Earth's rotation. I might be able to just turn this a little bit without loosening things and slide it back into the field of view without shaking it around and stuff. So that's a handy little thing. This mount back here is a little better quality one. It has two cables on it, flexible cables, that do the same thing. I can turn a knob to move the telescope up and down. I can turn a knob to move the telescope back and forth. And well, this one is shaking because it's sitting on carpeting and I do not have the tripod deployed properly at all. But anyway, so these are things you need to learn about your telescope that will be specific to it. So you want to, again, be able to do this in the dark without wondering about it, without thinking about it. Jim already covered eyepieces. I will repeat also that how important it is to, if you have if this telescope came with 2 eyepieces, here's my simple summary, the 20-second summary. If it came with 2 eyepieces, there's going to be one with a higher number, say the 25 on it, and there's going to be one with a lower number that might be like 10 or 12 or something. You always use the one with the higher number. That's going to be your lower magnification. That gives you a wider field, a much wider field of sky than the higher magnification was. So it's going to be easier to get something into that field of view. So when you're first trying to use your telescope, what most people find the most frustrating thing is getting things into the field of view first. And if you're trying to do it with looking through a straw or a high power eyepiece, that's going to be a lot harder than looking through, a hula hoop and seeing a wider area of sky, which was what the lower power eyepiece would be. So that bigger number, always start there. When you start getting good at finding things and centering things, you might say, well, I've got Jupiter in here now centered, and I'm going to switch out this eyepiece and put in my higher power eyepiece and see if I can still have Jupiter in there, or if I can just center it again on that. That's how you get to the higher magnification. Don't try to find things at the higher magnification. It's just frustrating. Talking about finders, so I'm going to actually pull the red dot finder off of this telescope and switch cameras. There's 2 little knobs on the front here that are 2 little nuts, arrow knobs that hold this on. So I can show it to you a little closer up. So there's the whole point of a finder telescope, or of a finder of any sort, is that the telescope looks at a very small area of the sky. The finder looks at a big area of the sky. And if, as Jim noted, you center the objects in the finder, so they're in the telescope, or whichever way you want to look at that, you can use the finder to aim the big telescope. And it's, again, as Jim emphasized, it's a really important thing. So here's this red dot finder. Let me set this white background up here so you can see it. This does not magnify the view at all. It just has a little window in it that if let's see if we can get this right. If I hold it up there, it makes a virtual dot on the little window that that in effect to the viewer makes it look like it's projected on the sky. It's not a laser beam. It's not projecting anything on the sky. But looking through that little window, I see where the telescope is pointed. Now, when this is mounted on the telescope, as Jim said, you aim the telescope at something on the Earth, the top of a water tower, the top of a cell tower, power line, something like that that you can recognize. And again, this is something to do at dusk or even do during the daytime or when you're just setting up the telescope. And then you look through the finder, and if that dot isn't right on the thing, this kind of finder has a knob on the side that moves it back and forth, and a knob on the bottom back that moves it up and down. So I can swivel this little finder back and forth and up and down to get it to match the view through the telescope. And that's something that after the first time you set up the telescope, probably when you use it in the future, even if you take it off, it'll probably be close, but every time you set up the telescope, you reset it. This guy is another non-magnifying finder. It's bigger so you can see this angled piece of glass that you're actually looking at when you look through it. But the Telrad, instead of having red dot in it, it puts a bullseye on the sky for you. So if I wasn't leaning over and shaking here, I could do that there. But that's what you see. It's kind of a handy thing. It's a much bigger finder. It's kind of handy because you can actually measure the sky with it, because the rings are different sizes. It has a 1/2 inch center ring and a 2-degree and 4-degree circle on it. This is a classic finder telescope. So it's actually a small telescope. If you got started in this hobby when I did, before there were these wonderful non-magnifying red dot or bullseye finders, telescopes always had a little telescope on the side of them. Same thing. It's just looking at, it's at much lower magnification than your main telescope. This is usually 5 times magnification, or 6 or 8 or 10. And so it looks at a wider view of sky. When you look through it, if I can hold that right, you will see the crosshairs in it. So the red dot is actually a reflection of something or other. But anyway, you can see the crosshairs as I wave it around there. So you're going to be seeing that water tower through this telescope. And this kind of arrangement is mounted on these rings. You just adjust these screws by tightening the one side and loosening the other to tilt it up and down or back and forth or around to get it to aim with the main telescope. But those are finders, we just call them loosely. And even if you have a go-to telescope, you need a finder. So let me get back up off the floor. And really important. And I think most good visual observers will tell you that whenever they set up their telescope, you know, it's getting dark out or whatever, one of the first things you do is make sure the finder is on. And maybe it'll be smack on, you know, from the last time you used it, but you always check it to make sure and you adjust it if you need to, because it not only doesn't do its job, it just frustrates you for the rest of the evening if when you put the crosshairs or the dot of the finder on the object, it's not in the telescope or it's way off at the edge because you didn't adjust it right. Okay.
Drew, we got some questions, some Facebook questions that are backing up. Maybe we can address a couple of those. So Craig says he's researching buying his first telescope, and he's kind of wondering the difference between an 8-inch Dobsonian and a 10-inch Dobsonian. Can you kind of speak to why one would be better than the other, or if there would be a noticeable difference?
Sure. I can do that pretty rapidly. So traditionally, telescopes have come in a certain range of objective sizes, especially once you got into mirrored telescopes, which came in 3-inch and 4.25 inch, and then 6-inch and 8-inch and 10-inch, and then 12.5, and then 16-inch sizes. And those sizes are actually kind of based on the geometric progression of light gathering. Theoretically, if you go from one size to the next, you're going to gain a 1/2 of a magnitude of what you can observe through it. And that may not sound like a lot. In reality, in practice, most people will find in casual observing that there's not a tremendous amount of difference in one step between, say, a 6-inch and an 8-inch telescope, or between an 8-inch and a 10-inch telescope. But the difference when you skip a step from a 6-inch to a 10-inch is going to be immediately obvious on a lot of objects. So that's kind of a subjective thing. That's not a really scientific way of looking at it. But at least back in the old days, I don't know what the current chatter is on things, but back in the old days, it would be, gosh, if you have a 6-inch telescope and you want to upsize, you're not going to notice a world of difference going to 8-inch, so you probably go to a 10. Same thing, we're going to 8 to a 10. You'd go from an 8 to a 12.5 to gain a whole magnitude of capture of what you can add. So what the difference comes in there is the size difference. And If both of those Dobbs are solid tubes, not truss tubes that come apart, do they both fit in your car? Can you fit the one and not the other? Thinking of the base too, because the base is going to be the biggest difference. Actually, the base size between an 8-inch and a 10-inch Dobb will be quite a bit bigger. So from my point of view, it comes kind of down to that. You could be very satisfied with an 8 and a little bit more satisfied with the 10, but it's not a huge world of difference. On the other hand, if you've got the money for either and it's just as easy for you to handle the 10 as the 8, I guess I'd say get the 10, because you do get half a magnitude more of faintness you can see out there, a little fainter galaxy or a little fainter star cluster or something like that. But that's a brief take on that. And again, it's sort of a subjective and opinion thing.
And that really only applies to stars, because planets are bright enough anyway that you're, yeah.
That your 4 1/4 is going. I mean, this is an 80mm telescope, and boy, the planets look great in that, for the magnification. So you don't need more than that 3 point something or other inches. That is for gathering for planets. But yeah, it's the difference between the 8 and 10 would show up in looking at faint galaxies, and not in the planets.
And just one note, I'll chime in, because I used to have a 10-inch Dobb. A 10-inch Dobb is pretty much the largest that you could fit in the back seat of probably your average car.
Yep.
Once you go to a 12-inch, you need to fold seats down and get a little more creative in how you would travel with that.
Should actually get out your tape measure and see, like I say, will this fit in my car?
Right.
You'll be frustrated if you get a new telescope and then you find you have to get a new vehicle too. That adds a lot to the cost.
Okay. So Craig, I hope we answered your questions. If not, chime back in, and we'll answer them again. And then you don't have a Dobb there, but maybe you could kind of show on the Newtonian. So Greg was asking, are there kind of any tricks for using a Dobsonian? How can you kind of show how you would move a Dobsonian around? And
so the Dobsonian is pretty much the same telescope, except instead of being on a tripod, they're both Newtonian reflecting telescopes, so they have a mirror in the bottom. The Dobsonian is just the mounting for it, and it is basically this mount. It's a central pivot that the tube turns up and down on, and then a base that it rotates on. And in this case, all of that is up here on a tripod. In a Dobsonian, that sits on the ground. The base is some sort of box generally that does this same thing. It has side pivots with a telescope tube and a base that swivels to go up and down. This is part of learning your way of using the telescope, period. You don't have, in the basic telescope, a basic Dobsonian telescope, you don't have any sort of readout of where it's pointing or something. You're using your finder telescope and your maps of the sky that I'll get to, and saying basically, that's really simple. If I see where the moon is over there, I use my finder, which I stole off of this one, and I point the telescope at the moon, and that's simple enough. Or if it's Jupiter or whatever, that's simple enough. When it comes to other things, you have to learn your methodology for figuring out where those things are. And that applies pretty much to any manual telescope. This one back here is the same thing. This is on a altazimuth mount also. And the finder on this telescope is actually, I'm not going to see it well against the closet here. It's actually mounted on the side of it here. But this is a red dot finder here. And we use this by turning on that finder, taking out our star charts, and aiming that dot in here onto the point of the sky where we think the galaxy is, or the star cluster is. And that's based by looking at a chart. The chart can be a book with a map. It can be on your phone if you're using a phone app that's you can zoom in on and see the locations of things in the sky. But again, it's this basic back and forth and up and down. The trick is once you've got something in here, I'm going to talk about mounts a little bit more. Again, Jim's telescope that he was demonstrating on has a motor that's tracking the sky. Actually, it's two motors that are tracking the sky. On that one, it's turning it sideways and up and down at the same time to follow things across. You have to do that manually with a manual telescope. If I'm facing south here, which I am, and the moon's up here, through the evening, it's going to head west and downward. So I have to constantly be adjusting this over to the side and downward as it goes down the sky. It's just something you practice at doing in moving. So I don't know if that isn't a whole class in Dobsonian use, but it's really basic, fairly straightforward, but it does take practice. I don't know if I answered the question well or not.
Yeah, Greg, if you have any more questions, we can kind of chime in. Well, one thing there's a little bit of a discussion on telescopes happening on Facebook, and I think one thing to chime in that there's kind of no perfect telescope. That's why if there was a perfect telescope, they would only make that one telescope. There's Newtonians and there's refractors, and then there's kind of the Smith-Cassegrains, which are the combination of the two, and each one kind of shows the sky a little bit differently, and some are more compact than others, and some are bigger than others, and it's really kind of a matter of personal preference when it comes down to it.
If you're watching us on Facebook, our old videos are on Facebook. What I would recommend instead going to our YouTube channel. I think it was our October fundamentals presentation, October of this last fall, was on choosing a telescope, and I went in depth on those differences between the different telescopes on that. So I would refer people back to that because I covered those points, and that point exactly, that there isn't one best telescope, that we really need to pick telescopes that match our ways of wanting to do things and our interests in what we want to see in the sky, and what clicks for us as far as we want a computer or we don't want a computer and things like that. So there's a good hour plus on just that specific topic in our October fundamentals program, which is available for you. Anything else that I should touch on here?
One more thing. So again, they're kind of discussing buying a 10-inch Dobsonian or an 8-inch, and I think they're talking about a Smith-Cassegrain. The big difference there, probably more than the aperture, is the cost that would be associated with it. And when you talk about a Celestron 8SE, the bulk of what you're paying for is the gears and motors that drive that telescope around. If you're willing to do everything manually, a 10-inch Dobsonian can look at the same stuff in the sky. It's just if you have to find it yourself, you have to drive the telescope yourself. So again, it's kind of personal preference, but if
it's entirely personal preference, it's entirely what works for you. As I pointed out more than once during the presentation in the fall on choosing a telescope, there isn't one best telescope. There's a lot of different telescopes for a reason, because they all have different features, including different mountings, and they're all better for one person or another, or one thing or another, one use or another. And in the end, the bottom line is the best telescope for you is the one that you'll actually use. If you get a telescope that has no computer on it and you're like, I don't know how to run things that don't have computers on it, then that was a mistake. If you get one that has a computer on it and it does nothing but frustrate you when all you really want to do is point at that thing in the sky over there, then that was the wrong telescope for you. So again, it's a matter of what clicks for you, what gives you the most pleasure, and what gets you out actually observing the most. Again, there's the classic thing of people buying too big a telescope. because big sounds really good. But if you never take it out because it's too much of a hassle to take a big telescope out and lug it around and assemble it all just to look at something for 20 minutes tonight, then that's not a good telescope because you didn't actually use it. Whereas a smaller one, this you could leave set up in your living room or your den or something or other and pop outside pretty much assembled and be observing in less than 2 minutes probably. And maybe you'll use that more. And that all of a sudden this became better than a 20-inch telescope. If you use this one and you wouldn't use the 20-inch telescope. So yeah, that's again, that's a different program on going back a step and picking a telescope. So I do recommend the October program, not just because I gave it, but it covers a lot of these points really in a little bit more detail.
Okay, one more question, then I'll let you get back to your program. We got a lot of questions tonight. This is great. I don't think I've ever had this many questions. So Joseph asked, any hints on swapping eyepieces during an observation? I usually knock it out of view, and the focus also changes. And he says, stupid question, do you ever grease the inside of the eyepiece holder?
Starting out with no question, stupid. I would never grease the inside of an eyepiece holder because you certainly don't want to take any risk of that than getting into the eyepiece in one shape. Any lubricant really. So addressing that particularly, yeah, that's an issue. It's going to vary from telescope to telescope with how much problem you have getting an eyepiece out and putting another one in without something moving around a lot. That initial thing I said about tightening up your mount is very applicable there, but also quite a few different kinds of mounts. Again, there's a lot of different mountings that have been made over the years and they're still being made now, and they're all designed a little bit differently, but quite a few of them have some sort of lock on it or another. The exception now to that would be a lot of the go-to telescopes, because I remember that when Celestron, no, it was Meade first, Meade came out with a go-to telescope a little before Celestron did, but they left their mount kind of the same and they left the locks on for the axes so that you could make them so they wouldn't turn. But then people were destroying their motors because they were trying to go to them with it locked or something. So a lot of cases they're designed now without locks on them. But if your telescope does have locks on them, the thing to do is to get Jupiter centered in here and lock the mounting. So, turn this knob and that knob so it doesn't turn easily when you go to change your eyepiece. That's the best you can do there. A lot of the go-to telescopes should either be always locked on their gears so you can't push them manually, or they should be on a clutch that should be adjusted to be fairly firm. So it's a matter of practicing. If you perennially have problems with being hard to get eyepieces in and out of your finder, I would look at the finder and see if there's some way that it could be slightly modified. This finder has a plastic ring at the top of it. It's a cheap telescope, so it's plastic at the top. I could sand the inside of that out if it was an issue. Make sure if you have a locking screw that it's backing all the way out before you go to pull the eyepiece in and out. But again, it's a matter of practice. Focusing, the default would be, say, figure every time you change eyepieces, the new one is going to need to be refocused from the old. If you get two eyepieces that focus at the exact same place when you're setting into the eyepiece holder, that's called parfocal. Some sets of eyepieces by a certain manufacturer sometimes will be made to be parfocal, so you can take out the 20 millimeter eyepiece and put in the 10 millimeter eyepiece and not have to refocus the telescope. But focusing should get to be such second nature for us that it really isn't that hard to do. Because as Jim pointed out, in focusing, my eye will focus different than the person standing behind me will, at least a little bit probably. So we're always looking through the telescope and tweaking the focus a little bit. So that shouldn't be a limiting factor, but expect that when you change eyepieces. But again, for it to not wiggle when you're changing it, lock the telescope as much as you can in place. It's I guess is the number one pointer. Something else?
I'll chime in and say sometimes on a manual telescope I'll cheat a little bit. I'll if I see what direction the sky is moving, I'll maybe put that object to the opposite side. So as I move away from the telescope to let another person look at it or to change eyepieces, by the time I'm done, it's maybe drifted into the center, where if it was at the edge when you start adjusting the eyepiece, then now the object's out of the eyepiece, especially when you're going from a low magnification to a high magnification, that object's going to be moving faster through that eyepiece. So if you cheat a little bit, you can maybe swap your eyepiece in time. And one other thing, and then I promise I'm going to let you continue your presentation.
I've gone through, so go ahead.
We want to say hi to Owen. Owen's 5 years old, and it sounds like he got a 6-inch Dob for Christmas.
Oh,
so,
well, I've met Owen, so congratulations, Owen. That's pretty, that's cool. So that will be a wonderful telescope for the rest of your life. So that's a great thing. So
okay, you can continue.
All right, where was I? Looking at my notes over here. Okay, so we're tracking. All I wanted to touch on a little bit briefly was, again, for the beginner point of view, and I kind of sidetracked there already, is choosing what to observe. You get a new telescope and you take it outside and the moon is up and you look at the moon and you say, I think that's Jupiter over there, and you look at Jupiter and then you're kind of like, well, now what? If you have a go-to telescope, it might help you a little bit figuring out what to look at next. But as Jim already noted, if this was on a go-to mount, this 3-inch telescope was on a go-to mount, it would have the exact same control that this company's 16-inch telescope would have on it. So the go-to catalog would be all 32,000 objects or something, 20,000 of which you can't see through this telescope, which you need, a 12-inch or a 14 or 16-inch telescope and on a mountaintop in the desert to see, visually through telescope. So you still need some kind of guidance about what to look for in your telescope. Even if you have a go-to telescope, you need to learn your way around the sky some, and there's no better way than starting out than with a planisphere. So this is a really inexpensive little accessory for observing. It's a wheel inside a holder, and it's got the days of the year on one scale and the hours of the night on the other scale, and you match up today's date with the hour you're observing, and it shows you what the sky is, and it shows you the bright stars and the basic constellations. And you can take this outside wherever you are, in your suburban yard or in a really dark place, and figure out what those stars are that I'm seeing up over in the sky there. So planisphere is a great thing. You can use your phone app. I don't have a phone app, but that's going right now. But to show you the sky, I still think this is better. I think the phone apps are kind of clumsy. I know that sounds very Luddite to say that, but this doesn't have problems with trying to decide where you're looking and shifting back and forth on you and not showing you what the proper scale is, because you can zoom in on the phone app or zoom out and it's like, well, wait a second, this doesn't look like the sky anymore. It's bigger or smaller or whatever. This is always just kind of fixed there. It's a handy, you can study this during the daytime, set it for tonight and look at it and say, oh, well, that'll be Vega setting over in the west as I go out tonight. So I'll look for that. And great resource. Then you need to learn what to expect to see in your telescope again. And some of that will come by practice. Say, well, I saw in this list that there's a 6th magnitude galaxy, or say a 10th magnitude galaxy. And I looked there and I looked for it all night and I didn't see it. So I kind of wonder whether I can see 10th magnitude galaxies in this telescope. Or it might be an 8th magnitude galaxy and you say, oh, I got it. So I know I can see that in this telescope. So learning that is important, and that's going to depend on what your telescope is, how good your eye is, what your observing conditions are like where you're looking at. But then you need to know your way around the sky. There's sky charts of all sorts, if you're a manual user, that just are maps of the sky that show you the stars and then show you where various objects are that you might want to look at with your telescope. It's kind of an essential thing. The planisphere is going to show you where the constellations are. Not many of them have actually the navigational stars listed on them. So Jim mentioned that when you use you set up your go-to telescope, you might end up having to look at the star Mirfac or something or other, because it says I'm looking at Mirfac, and you're like, well, what's the star Mirfac? But a chart would maybe tell you that. Maybe your phone app will tell you that, or your planetarium software on your computer would tell you things like that that help you find your way around the sky more. And then there are all sorts of lists of objects. There are whole books on things to observe in the sky. There are articles in magazines like Astronomy or Sky and Telescope every month about this star cluster to look at, or this group of galaxies to look at, or something like that. And so there are resources like that. The internet, the web, is full of resources on objects to look at and stuff. So you need to know what the capability of your telescope is and know basically how to find things with whatever your telescope setup is. And then you can start making lists of, I'm going to go out tonight and I'm going to find these 2 or 3 things that I've never seen before. And you can spend your whole life doing that, because there's thousands of things to look at in the sky, even a small telescope. So keep on exploring that way. The last thing I had down was we were asked to give a brief thing about telescope care. It was suggested we do. That's something that we've done whole presentations on, cleaning and caring for telescopes. And so there's a lot of details to go into, but I'll hit just a couple of really key points now. First off, clean and dry. Both the optics, especially the optics, but then also the mechanical parts, and certainly the electronic parts if you have a telescope with electronics in it. Clean and dry are the key. If you're going to use this outside, and when you bring these in, they might not be clean and dry anymore. They certainly might not be dry. In any time of year, we can get dew on telescopes. It'll be frost at this time of year. If you're out in January, you can get frost on the telescope. In the summertime, it might just be dew. It's condensing through the night as the air temperature drops. You don't want to leave that on the telescopes. So the key for clean and dry, it may seem counterintuitive, put the caps back on, put the eyepieces away, cover the telescope before you bring it back inside, and that'll help keep the interior humidity in the warmer area inside from condensing on the telescope or in the telescope while the telescope warms back up. After it's warmed back up, maybe the next morning, when it's in house temperature, take the covers off and make sure any moisture on the inside is gone. Same thing with eyepieces. It's better to put them in a case outside, close that up, and bring it inside and let it warm back up. The clean part, we try to keep things clean as we use them. We learn to be careful when we're handling our eyepieces to not touch the lenses. We certainly, if you have a lens in the front of the telescope or a corrector plate in the front of the telescope, you don't touch that really anytime, hopefully. So keep it clean in the first place. As far as storing the telescopes, I am not a fan of keeping telescopes in garages. You get broad swings of temperature and humidity. Even if your garage is really clean, it's probably not as clean as somewhere in your house would be. So keeping it clean in the first place for, again, all those parts, for the optics, for the mechanics, and for electronics is a key. If things do get dirty, again, I'm sure we'll be doing programs again every couple of years. We do a program on cleaning optics, which can fill an evening. So we'll do that again before long, but there are ways of safely cleaning optics. And it's actually better if you have lenses, especially they get dirty, it's better to clean them than to leave them dirty. So that's something to explain. The last thing that we were asked about is collimation. That's a big word. It's a simple, very simple principle that you really should know basically what it means for your telescope. So there are a lot of optical parts in a telescope. This one, for instance, has a mirror down the bottom that's gathering and focusing the light. It has a second mirror up at the top. It's a diagonal, it's a small mirror that's hanging in the tube there that bounces the light being focused by the main mirror out the side of the tube. Then it's got this focuser assembly that holds an eyepiece in it. So these are all parts of things in the optical path of the telescope. And each one of those things, the mirror here, the mirror up here, this finder, or the focuser, excuse me, here, and the eyepiece that goes in it, each have kind of a center line going through them. They each have their optical axis where they do their job the best. This main mirror does its job the best looking straight at something, not way off to the side or one way or another, but straight at it. Collimation means adjusting the angles and positions of all the different components in your telescope so that all of those lines are the same line. So the light comes neatly through and hits the sweet spot of the main mirror, the second mirror, the focuser holder here, and the eyepiece that's in it. And in some telescopes, like a refractor like this, one hopes that everything is anchored in place here well, and it doesn't get out of adjustment. And you can have a telescope, I've looked through telescopes, this sort of design that were 100 years old, they were still in perfectly good alignment. Ones with mirrors, on the other hand, tend to be a little more finicky the way they're made, and then they're mounted. So on a Newtonian telescope like this, you'll almost always have adjustment screws. And most optical adjustments come in a triangle. They come in threes. So you can tilt something by moving one of the corners of the triangle in and out, or two of the corners in and out. So collimating means lining up this mirror to that mirror, potentially the second mirror to the eyepiece holder, and potentially even the position of the eyepiece if it's can get off angle. So it really depends on your telescope what the need for checking collimation is. Again, if it's a well-made refractor, it's probably something you'll never gonna have to worry about. If it's a reflecting telescope like this, that's like one that's sitting over in the corner over here, which is not a camera, which gets taken apart completely, dismantled between uses. Every time that the base is reassembled to the uprights on it that hold the top of it on it, that have the second mirror in it, I have to check the collimation to make sure it's all in good alignment. It's actually a well-made thing, and I can reassemble it all from its many parts, and oftentimes it's still smack on from the last time I did it, but I have to check it every time. Telescopes that get transported around a lot, especially reflecting telescopes, can get a little out of alignment just from being shaken around, from being in the car and bouncing around or whatever. So it depends on your telescope. If you have a reflecting, especially a Newtonian reflector, you should get used to finding out and learn how to do it and get used to checking the collimation to see how whether it's good or not and whether it needs adjustment. Again, you may hardly ever have to do it, but you need to learn how to check it. If you have a Schmidt-Cassegrain telescope, like the one that Jim was demonstrating, it's kind of a mixed bag. In theory, back in the day, Celestron would have said early on that that's something you never have to fiddle with in their telescopes. In the years after, users who found that that's not necessarily true, that they can get out of alignment, that the secondary mirror can get out of alignment, and but they're a harder thing to collimate than the Newtonians. Really pretty simple once you learn the basic techniques. People have really messed up their Schmidt-Cassegrains by turning screws that they shouldn't have turned, or turning them not understanding what exactly they're trying to do. So again, that's almost a different, it is another whole program on really how to address that effectively. That's the things on my notes down here. that we're my turn to cover. So is there anything else, Jim, that we're?
Well, I'll just comment on collimating on a Schmidt-Cassegrain, unless you have an obvious issue that you can see that a star is totally not aligned, I would say try not to touch it.
Right.
Because it probably shows up manufactured in a way that it's good enough. If you accidentally dropped it a little and something shifted and then it's not working right, then I would say, yeah, collimate it. But if you're focusing one night and you go, boy, that star is just not as sharp as I think it should be, I don't think collimating's it's gonna cause you more frustration than the improving your views, probably, for the most part.
Yeah.
And then also I'd say that I think probably the smaller the reflector, probably the less collimating you need to do. So a 6-inch, you probably collimate it one time and maybe never really touch it again. If you have a 12-inch, that bigger mirror, just gravity alone is making that shift a little more as you're driving around in your car. So that probably needs to be collimated more often than a smaller scope.
I think it's something you can learn fairly easily, is how to check your collimation of your telescope by looking at a star. And in 30 seconds, I can tell whether the issue somebody's having with the telescope is collimation or not, just by observing a star. So that's a technique. That's what you want to do. Well, with my 12.5-inch over here, when I set it up, I eyeball it, and I during the daytime, looking through the assembly, tell basically whether everything's in alignment. Then I have a couple of simple tools that I put in the IP folder. I look through to make sure. And again, it's a matter of all of these different angles being right of the different parts. But I've oftentimes assembled that telescope and checked it, and it was fine. But it's exactly like the alignment of the finder, that it's just something that when I set up the telescope, I actually would check the collimation first, because when you recollimate the telescope, it won't be in alignment with your finder anymore. So that's first, and this is second. And both of those steps, it's way less than 5 minutes to check either of them, to see whether there's any adjustment that's needed. And once you learn how to do it, neither the adjustments take more than 5 minutes either. So really, so it's not something that's threatening, but you do want to understand it, and you don't want to dive into it. It's like, it's like surgery or something. You don't do it if you don't really need to do it. It's because you're just opening yourself up for complications. Anything else on the question list?
Yeah. So Joseph asked, are there oversized planispheres out there? Kurt actually responded and found a 16-inch. Have you seen really big planispheres?
That's as big, except for ones that were made for like putting out exhibit. In publication, I think I've got a 16-inch over there somewhere. I've got a few of them. I've got a really tiny one that is nice southern sky one so their planisphere is optimized for a certain latitude, and shows the angle of the sky that you're getting, how high above the horizon Polaris is going to be, actually. But size-wise, yeah. But, welcome to the problem of being middle-aged or older. You can't see small things in the dark. If you're going to be using maps outside, I still almost prefer a map to a screen, because I have a couple of really good flashlights that I like for lighting up a map surface or a book. And I can really minimize the amount of light reflecting back into my eye and still manage to. So the trouble with being my age and wearing reading glasses, which I only need these for seeing things that are closer than my arm I can reach, that I'm constantly taking off my glasses to look up in the sky or look through an eyepiece and then putting them back on to look at a chart or whatever. But hey, that's life. You know, you can actually, I don't have one with me, having a magnifying glass with a flashlight built into it. I've got one somewhere around that had a little bulb in the back of it that's back from the incandescent days, but I painted the bulb red. Now you could probably get one with red LED in it. That's a handy thing for reading small stuff in the dark. But yeah, that's life. It's hard to see little things in the dark when you're older. Anything else?
Yeah. So Derek asks, how much observing would you recommend before trying astrophotography, and would I need a crash course or more in photography to attempt astrophotography? So I'll just chime in real quick and say, if you think you're going to do astrophotography, you need to start off with the right type of mount first and foremost. So if you have, as Drew was showing earlier, the telescope goes, to left and right and up and down, that's bad for astrophotography. You would want an equatorial mount that's gonna move in the same arch that the sky is rotating in. So it's tough to retrofit a alt-azimuth scope to do astrophotography after the fact. You end up throwing a lot of money at it to try to convert that, I guess. So I'll say that just first off. We did a program last month on kind of astrophotography for beginners. So that's on our YouTube page. And that
was basically mainly with a DSLR camera, which is
a
camera you can use for normal daytime photography too.
And then the other thing, so I tried to do astrophotography and I failed at it. So I'm one of the things that I noticed right away is when I was sitting outside trying to do astrophotography, I was bored, because now this nice big fancy telescope that I have has a camera hooked up to it, and then I can't use it anymore. So the first thing, after a week of trying to do astrophotography, I went out and bought a second telescope so I could look through one while the other one was taking pictures. So it can be a slippery slope on your finances if you...
during the October presentation on choosing your first telescope, I said at the beginning of it, I'm talking about telescopes for visual use, and I caught heck for that from some people because, well, it's like, well, I use the same telescope for the two, but my friendly advice is that I think both astrophotography and visual observing used to maybe be simpler than they are now. Astrophotography certainly has branched from like 4 ways you can do astrophotography to dozens of ways you can do imaging of some sort or another of stuff up in the sky, of celestial things. It's a whole tree that's branched out in many directions. And in some cases, some of the stems and the parts are very similar to the tree over here that we visual observers use of things. In other ways, it's gone off. Parts of it aren't the same. You had the perfect telescope to do one kind of astrophotography. It would not be the right telescope to do a different kind of astrophotography. And so it's really a complicated branching woods of stuff out there. And so it really takes backing up and saying, what do I want to accomplish in the end, and what do I need to do that? And again, in some cases it might be, well, I could buy this one telescope and I can both observe Pluto with it because I want to observe Pluto with my eye, and I can take pictures of galaxies, and that would be great. But there's going to be a lot of times when it's like, well, this telescope that's optimized for taking pictures of galaxies is probably going to sit with the camera on it all the time because I have to dismantle it to put the camera on and this and that, and I'm not really going to be observing with it otherwise. So it takes study. I wish there was somebody could even get an hour presentation that would cover all the bases of it, but it's a complicated thing.
And part of his question was, should he take a crash course in photography? I would almost say you need more of a crash course in Photoshop and how to optimize your.
And we did have one of those in a monthly meeting back in June, I think, was our presentation on processing digital astrophotos. So that's on our YouTube channel too. So, but yeah, that's a whole thing unto itself. You not only need, for that type of setup, you not only need the telescope and the camera, you need the computer with all the software on it and the wherewithal to use all that to actually come out with a picture to show on the end, because it doesn't come out like the old Polaroid cameras used to with a picture of something that's outside the telescope. It's a lot of work there. Anyway, we're getting kind of along in time. Is there anything else?
I think that's our last. I think that's our last question.
Okay. Well, I hope this has been helpful for people. We will get this episode edited and put onto our YouTube channel too for future reference. And let's see, this is the fundamentals program. So the next scheduled presentation will be our February regular meeting program on the first Tuesday in February. Do follow us on Facebook though, or if you're a member, watch the message board. We really are overdue to get out and do another observing session, but the weather has not been too cooperative for a night of doing video astronomy, but we'll try to pop that up as soon as practical. Otherwise, I guess we're ready to sign off. Jim, anything else you have?
Nope, that's everything. Thank you, everybody.
Yeah, take care, everybody.